Friends, very good morning to everyone. We were dealing with the principles of green chemistry. We have seen there are 12 principles in green chemistry. The first and foremost is to prevent the formation of the waste material, which can be achieved by atom economy, you avoiding the synthetic routes which are harmful to the environment, utilizing the greener chemicals and greener solvents. However, in general, we heavily depend upon the petroleum products. And we know that petroleum products are non-renewable resource. It is a fossil fuel. And this causes environmental pollution. The greener approach is use of renewable feedstock. Instead of obtaining the raw materials from the petrochemicals, we can obtain those raw materials which are the versatile chemicals from the biological sources. That is, we are avoiding the fossil fuel. This refining of organic compounds from the plant derived materials, which are called as biomass, is having less pollutants production than refining process of petrochemicals. That's why this has been utilized as a greener approach. Many of the pharmaceuticals, plastics, agricultural chemicals are produced by using the biomass as the feedstock. This is another approach where we reduce the formation of pollutants and protect the environment. That's why this is another principle of green chemistry. For example, levulinic acid, a versatile chemical. Acetylbutanoic acid can be obtained from various renewable resources. One of the resources are sludge obtained from the paper mills, the waste wood, that is the residues of agriculture, the municipal solid waste or the waste papers. All these renewable resources of plant origin, we can obtain levulinic acid. Levulinic acid is a versatile platform chemical. This is used to obtain 1,4-butanediol. This can also be used as a starter raw material to obtain acrylic acid. This is used as a starting material for production of tetrahydrofuran, a versatile solvent, and methyl tetrahydrofuran, the derivative of tetrahydrofuran. It is also used as a raw material to obtain delta amino levulinic acid. This is represented as DALA, and this is non-toxic and biodegradable herbicides. Instead of using chemical herbicides which are non-biodegradable, are less biodegradable, we can substitute by delta amino linolenic acid. Butyrolactone, precisely gamma butyrolactone, can be obtained by using linolenic acid as the starting material. By phenylation, I'll get corresponding diphenolic acid. This methyl tetrahydrofuran is used as a fuel additive, and also this is used as a base for production of succinic acid. By a single linolenic acid as raw material, we can produce n number of other chemicals. And this linolenic acid can be obtained from renewable resources. This is the greener approach. That is another principle. Obtaining the raw materials from renewable feedstock. Another principle is to use shorter synthetic routes than that of longer synthetic routes. When we use shorter synthetic routes, we are avoiding the unnecessary steps. When we avoid unnecessary step, it minimizes or it avoids the usage of the reagents, and also it reduces the production of the general waste. For example, industrial routes for propylene oxide preparation or production is the chlorohydrin process, which is the oldest process, which involved the treatment of propene with chlorine and water at 45 to 90 degrees centigrade to give corresponding chlorohydrin. Two varieties of chlorohydrins are produced, and in the treatment of a base like calcium hydroxide, I'll get corresponding propylene oxide and calcium chloride. The newer approach is take the same propane and treat with titanium silicate and hydrogen peroxide at 40 to 60 degrees centigrade at 20 to 25 bar atmospheric pressure. I'll get corresponding propylene oxide along with water as the byproduct. In the first process, it is a two-step process. The newer process is one-step process. I have minimized the number of steps, and thus I have reduced the usage of chemicals. Thus, the waste generation is also reduced. This is another principle of green chemistry. Usage of shorter synthetic route in place of larger synthetic route, and this gives atom economy as far as possible. Use catalysts. Use of catalyst reduces the quantity of reagents what we use. As we use the lesser reagent in quantity, lesser waste is produced. The catalyst lowers the activation energy, and hence it makes the reaction process more easier, more economical. And always it reduces the usage of starting material when compared to non-catalytic reaction. Thus, better yield is achieved and better atom economy is achieved. The reactions which are impossible are made possible and feasible by using a catalyst. Catalytic reduction by using palladium or platinum as catalyst or Rani nickel as catalyst, which is not feasible. Hydrogenation. The hydrogenation is made feasible by using this catalyst. The newer approach is using greener catalyst. Palladium or platinum or nickel are not greener catalyst. The greener catalysts are nanocatalyst using gold nanoparticles, silver nanoparticles, etc. for the efficient synthesis of organic compounds. And another alternate approach for catalysis is biocatalysis. Instead of using nanocatalyst, use enzymes as catalyst. The beauty of enzymes is that the reactions takes place at ambient reaction conditions of 30 to 40 degrees centigrade, slightly above the room temperature or if possible at room temperature. Thus, use of catalyst is a greener approach. And this is one of the another principle of this green chemistry. We have to design the products which are easily degradable. Design for degradation. And these degraded products, what we get, should be environmentally benign. And this degraded product should not persist in the environment for the longer time. The problem occurs in polymer synthesis. The polymers or plastics are non-biodegradable many of the times, or even if it is biodegradable, it takes years together. And many of the insecticides also are non-biodegradable. As I have told, delta aminolevulinic acid, which is biodegradable insecticide, can be generated in place of other insecticides. This is the another principle of green chemistry. And another one more principle of green chemistry is real-time monitoring and control of pollution prevention. What it means? It is developing the analytical methodologies to carry out the in-process monitoring in real time for the formation of the hazardous substances. Before it forms, if it is identified, we can reduce it by taking the steps, or we can prevent the formation of that hazardous substances. And the route of synthesis, what we develop, should be inherently safe. And as far as possible, it should be able to prevent accidents. Means we have to develop a synthetic route in which there is very less chances of chemical accidents by release or explosion or by fire. You have seen the Bhopal tragedy of 1984 because of the leakage of methyl isocyanate. Accidentally 15,000 people died, many got injured, and generations of human beings are affected by teratogenicity of caused because of methyl isocyanate. The manufacturing plant should be designed such that it eliminates all the possibilities of oxidants during the process of operation. Ultimately, green synthesis is achieved by green chemistry, and I can give this as an example. All 12 principles are not achieved by a single one. Even if 3 or 4 or 1 or 2 are met, it is a green chemical approach. The ibuprofen and NSAIDs, which is used as painkiller, which has been marketed in the name of Advil, Motrin, Brufen, Mediprin, etc. 28 to 35 million pounds of ibuprofen is produced every year. And for the production of this 35 million pounds, we are generating 37 to 46 million pounds of waste. Ibuprofen is 2,4-isobutyl phenyl propanoic acid. The first approach was given by Brown company, and that's why it is named as Brown synthesis. It involved the treatment of isobutyl benzene with acetic anhydride in the presence of aluminum chloride to give the corresponding para-acetyl derivative, which was treated with chloroethyl acetate in the presence of sodium ethoxide to give the corresponding propylene oxide derivative, which upon hydrolysis in the presence of an acid gave corresponding aldehyde compound, which was treated with hydroxylamine to give the corresponding oxide. The oxide has been reduced to nitrile, which is oxidized in the presence of an acid like concentrated sulfuric acid to give ibuprofen. In this approach, 40% atom economy was achieved. This is given by Brown. That's why it is named as Brown synthesis, and this has been utilized by Boots company for synthesis of ibuprofen. The newer approach was given by another company, and this is given as greener approach for the ibuprofen synthesis, where they used the same isobutyl benzene acylated with acetic anhydride and hydrofluoric acid to give corresponding acylated product, which was reduced with ranny nickel to give the corresponding alcohol, which was treated with carbon monoxide and palladium to give ibuprofen. The first one given by Boots company was achieving 40% atom economy, and in this greener approach, the 6-step synthesis has been reduced to 3 steps, and that's why atom economy achieved was 27%. The BHC company is now called as BASF Corporation. BASF stands for Badish Aniline and Und Soda Fabrik. This is a German's largest chemical company, which was founded by Friedrich Engelhorn in year 1865. The first employees were Fritz Haber and Karl Bosch. That's why this is named as BHC company before. And this is how we achieve the greener approach. Or ultimately, green chemistry is a philosophy where we strive to reduce the pollutants formation such that we can sustain the earth for the longer time. Ultimately, BHC processor, which is now called as BASF Corporation, BASF process gives greater throughput and better yields, achieving a better atom economy using less feedstocks and using lesser solvents and producing lesser waste. I can summarize this 12 principles within this figure. First principle is for prevention of formation of waste by achieving atom economy or by avoiding harmful synthetic method, reducing the product toxicity, using safer solvents or no solvents, avoiding higher temperatures and pressure by using renewable resources, omitting the unnecessary derivatization, utilizing catalysts, and designing the easily degradable products which were environmentally benign, developing in process monitoring and preventing accident. This figure is adopted by Wiley, though green chemistry is not a single solution for all the environmental problems, but it's a philosophy or a fundamental approach to prevent the pollution and sustain the earth. In the next presentations, we'll look how this green chemistry achieved by utilizing the different techniques. Till then, have a nice day. Thank you.